So we're going to talk about condensing logarithms. That means combine as one log. And then what I should mention before is that in order to do these properties using power property, product, and quotient, they have to be the same log base. So in this example, you see that it's log base 3 and then the other part is log base 3. So it's okay to combine. If they're different log base, then we cannot do that. So again, they have to be the same log base in order to condense as one. So our first example is 10 log base 3 of x plus 5 log base 3 of y. Now, we always, for condensing, check for power property first, meaning if there's a number in front of log, and then after that, do the product or quotient property from left to right. So whichever comes first when you start from the left side, as you progress to the right, whatever comes first, product or quotient. Now, there's another thing I want to mention. So when you have a radical, and this is when you're doing expanding, if it's the b root of x to the a power, you can rewrite it as x to the power of a over b, the rational exponent. So, if you have something like this in the beginning, x to the a over b power, you can rewrite it as the b root of x to the a power when it comes to condensing. So, step 1, power property, meaning we have to look for the numbers that are in front of log. So we have those two. So what we're going to do is we're going to move the number by x and by y as exponents. So we're going to move here those numbers. So it's going to be log base 3 of x to the 10th power plus log base 3 of y to the 5th power. So there's no more numbers, so we finished with the power property. Now we're going to do product or quotient property from left to right. So as I look from left to right, I only see one operation, which is the plus. So that means we're going to use the product property. When it's plus, that means we're going to multiply these two. So using the product property, we can just write it as 1 log base 3 of, now since it's just x by itself, I can just write x to the 10th power times, since y is by itself, I can just write y to the 5th power, and there we go. So now we have log base 3 of x to the 10th power times y to the 5th power. So that's all we can do since we finished with the power property and the product quotient property from left to right. So this is our answer. In example 2, we have 3 log base 5 of 4 plus 2 log base 5 of x divided by 3 plus 4 log base 5 of 11 divided by 3. So, now usually we do the power property, but before we work with power property, we have fraction. So what I'm going to do, I'm going to factor out the fraction with the number in front of log. So if you have a number in front of log, it's going to be part of the fraction. So again, a number in front of log is going to be part of the fraction. So I'm just going to rewrite the whole thing where I factor out the fraction from these two logs. So 3 log base 5 of 4 plus, now since there's a 2 on the top and a 3 on the bottom, so I'm going to write as a fraction, 2/3 log base 5 of x, and then plus, so same thing, 4 on the top, 3 on the bottom, I'll write it as a fraction, so 4 divided by 3, and then just the log base 5 of 11. Alright, so I got the fraction out from the log basically, and it's in front of log. So what's going to happen next is the power property. That means we're going to move the exponent, or the number in front of log, as exponents. So I'm going to write where all these three, since they have numbers in front of log, they're going to all have exponents. So log base 5 of 4 to the third power plus log base 5 of x to the 2/3 power plus log base 5 of 11 to the 4/3 power. Alright. Now, they all have exponents, so we can combine them. So, we can combine as one log, so log base 5 first one is 4 to the third times x to the 2/3 power times 11 to the 4/3 power, close parenthesis. Now, I can't just leave it like that. See, since I have a rational exponents, meaning this, that means I'm going to convert into a radical form. So, if you pay very close attention, what our denominator is our root. So if our denominator is to the power 5, then it'd be the 5th root. If it's the denominator 4, then it'd be the 4th root. So in this case, these two both have 3's. So these two would be in the cube root. And then our numerator would just simply be inside the root with the x or with the number. So the numerator is the exponent for what's inside the radical. So what I'm going to do, I'm going to write log base 5. Now this is just a regular whole number, so I can just write it as 4 to the third, leave that alone. Now since both of these have 3 as a denominator, so I'm just going to write a big cube root. So cube root right there. Now the number should go first before the variable. So I'm going to have 11 to the 4th power, because that's the numerator, and then x to the 2nd power. So now the cube root covers 11x to the 4th power and x squared. And now I'm going to close it with parenthesis. And then that's all we can do. We finished with power property with all the exponents. And then we finish with the product property because they all have plus. And then I convert any rational exponents into radicals. In this case, the rational exponents, the denominator was to the third, so it's being cube rooted. So this is our answer. Alright, so in example 3, we have 5 log base 7 of x minus 20 log base 7 of y. Alright, we don't have any fractions, so we don't have to worry about this part. So we can go straight into it. Power property. We do have 5 in front of log, and we do have 20, so we're going to move it as exponents. So I'm going to rewrite it as log base 7 of x minus, well, x to the 5th power, log base 7 of y to the 20th power. Alright, we finished with that. Now, check if they're the same base. They are. So we can do product quotient property from left to right. So as I'm looking from left to right, I see we have a minus. So I'm going to underline here that this is a minus. So that means we're going to use the quotient property. So the quotient property it basically means there's going to be a fraction. So we're going to write log one time only, log base 7. Now, what comes first from the left side? So from the left side, this came first, so x to the 5th power. So I'm going to write it as a numerator, x to the 5th power, and I don't need a parenthesis because it's just x by itself. And then fraction line, and then what comes second is our denominator, so y to the 20th power, and then I'm going to close it with parenthesis, and then there's nothing else I can combine, rearrange, so that's pretty much our answer. So it's log base 7 of x to the 5th power divided by y to the 20th power, and then this is our final answer. Alright, so example 4, we have 5 log base 4 of x divided by 6 minus 16 log base 4 of 7. So here we do have a fraction. So what I'm going to do is just like in example 2, I'm going to factor out the fraction. So in this case we do have a number in front of log, so that number will be the numerator, while this will be our denominator. So again, I'm just going to factor out the fraction just from log, meaning it's going to be in front of log. So our number in front of the log at the top will be 5, so our numerator will be 5, and then over 6. So 5 over 6, and then log base 4 of x minus 16 log base 4 of 7. So again, we have to do this before we can work on power property, because now we have this. So what's going to happen? We got all the numbers in front of log, there's no more fraction, so these numbers will be moved as exponents according to the power property. So what we're going to have is log base 4 of x to the 5/6 power minus log base 4 of 7 to the 16th power. Alright, so there's no more numbers in front of logs, and then they are being used as exponents. Now, we do product quotient property from left to right, so as I'm looking from left to right, I see there's a minus. So that means it's going to be a quotient property. So we're going to have a fraction as our answer. So what's going to happen, we're going to write log base 4, because again, in order to do product quotient property, they have to be the log base, they have to be the same. So log base 4, and then what comes first is the numerator. So this x to the 5/6 power over 7th to the 16th power. And close it with parentheses. Alright, now it looks like it's almost that's done, but it's not, because now we have a variable, or we could say a rational exponent, so just like this. So what we're going to do with this rational exponent is convert it into a radical. So what we're going to do is we're going to convert x to the 5/6 power into, let me write out the log first, so log base 4, now the numerator, our denominator, the 6, would be outside the radical, and then our numerator will be inside with the x. So since we have x, our numerator, which is a 5, will be with the x. So it'll be x, and the numerator is 5, so it's going to be x to the 5th, and then I'm going to write the root, and then what was our denominator will be outside the root, so the 6th root, and then over 7 to the 16th power, and then that's pretty much we can do. There's nothing else we can do, because we just finished converting rational exponent to a radical. So I'm just going to close it with parenthesis, and then parenthesis, So now we have log base 4 of 6 root of x to the 5th power over 7 to the 16th power and then that's our final answer.